about which one should I start with? Let me think. I don't want to mix them up, so let me think. Should I start with this one or should I start with this one? The topic is one. It's about ray diagrams, but it's two. Let me think. If I start with these ones for ray diagrams, and then I do the characteristics of lenses, and then I end with the other ones. Let me think. Okay, I'll start with correcting sight. Let me just start with this one of correcting sight. There are not a lot of questions. Can everybody see my screen? So the first question I'll be doing is about correcting the sight. Now we have started. Sorry, today we started late. I was a bit slow today. I'm sorry for that. I'm trying to wave to everybody so that people can join. Okay, here's the thing. Let's talk about correcting the sight. Let me just give you the things. It's so easy. Everybody, listen. When we talk about sight correction, we have two types of problems. So let me quickly write for you. Can you see my screen? Can you all see? Hello? Yes, let's quickly put the things that you must know so that we can quickly answer the questions without. I'll be moving fast because we're late. Correcting sight. If we are talking about correcting the sight, there are two types of problems that people can have. A person can have short-sightedness and a person can have long-sighted. Here is what happens. Your eye is like this. Let's just put it, the diagram of your eye. The way, let's put it the way which it is going to be in here. It's just a circle, right? With like something like that. So it's just going to be a bulb. So it's a circle here. Circle, which bends like this. Okay? We know that this is the cornea, the outside or whatever. We don't care. So here is what I want you to know. When, yes. This is physics. There are two types of problems that people can have. Are you listening? We have two types of problems that people can have. What happens is this. When you are seeing well, light should be made to come right here by your lens. If you see well, okay? If you see well, what happens is light will come in. We usually use 3 rays. So it's like the lens is a little bit inside like here. So the rays will come in. Rays will come in like this. And then they'll be made to meet right at the retina here. So they'll bend and meet right at the retina, okay? So it's like they come, yes. This is a person who sees perfectly. A person who sees perfectly sees like this. This back here is the retina. This is where you have the receptors. So this is the only place where you can see. Light should come here. This is good sight. Students, everybody, can you hear me? Kelly? Okay. Look at what a long-sighted person is like, guys. Look at what a long-sighted person is like. Their rays come in, 3 of them. The one at the center, of course, just continues straight. But look at, yes. The experiments, what do you mean? You mean the videos? No. Use the YouTube link right now. Can you use it? Yeah, on live videos, Here's what happens. If a person is long-sighted, the syllabus, the past paper can ask you, this is a long-sighted person. Let me show you, these are the most important things. So the retina is here. When a person is long-sighted, the other word, of course, they can call it, I'm making a mistake. Hyperopia. Long-sightedness. Doesn't matter. Just know that the rays meet outside. So what you must know for you to do this sight correction, you need to just know two things. Listen, the rays should come here. Long-sighted people, rays meet outside. Okay? That's what we mean by a long-sighted person. Now, what you do to fix a long-sighted person, to help them to see, is you're going to give them a converging lens. It is what is used to help long-sighted people. Are we okay? Long-sighted people, what you do, here is what you do. I'm going to copy this diagram. This is how you help a long-sighted person, class. Look at how you help him, Lechagwa. You're going to say, oh no, brother, this is not right. So what you come and you do is, Lechagwa, you come in front of this and you put a converging lens. Are you seeing? You know what it's going to do? It is going to bend before they meet here. So the rays will come in, come, then they'll, okay, you put it right in front of his eyes, of course. So they come like this, like they were doing. Then they'll be made to bend a little bit, you know. This one goes straight, but they'll be made to bend a little bit like this. Then when they meet here, they will be now made to bend and meet at the same place. Have you seen it? This is a convex lens. So what is it? What is the first thing you know? You know that a long-sighted person, his rays meet outside. They can ask you, if you're long-sighted, your rays meet outside. You can only see things that are far. That's why you are called long-sighted. You see things that are far. It's because your rays are going to be meeting outside the retina like this. So they can help you to see by giving you a convex lens. Pardon? Yes. Okay, let me explain again. Let me ask you questions so that we move together. What is to be long-sighted in terms of diagrams? Okay, to be long-sighted in terms of theory, it means you only see things that are far away. Yes, if you're long, okay, I'll change the position, I'll lift it up a bit. If you're long-sighted, it means you only see things that are far away, right? So that is in terms of theory. Then in terms of diagram, if you're long-sighted, this is what happens. Your rays meet outside the bulb. Is it true that they meet outside like this? Is it true? Huaba, are you seeing what happens to the rays if you're long-sighted? Where do they meet? If you're long-sighted, where do the rays meet? Thank you. So that's the first point you must know. They can ask you that. Long-sighted people, their rays meet outside. How do you then fix? Yes, this convex lens will help to have the rays meet here, right by the retina. Okay? Anita, can you hear me? Okay, good. So that's a convex. So long-sighted, you fix with a convex lens. Then this is what we call short-sightedness. When a person is short-sighted, obviously, in theory, it means they can only see things that are close, right? They can only see objects that are close. This is a short-sighted person. They see short distances. Now, in terms of the diagram, Here is what a short-sighted person sees. Class, in terms of the diagram, here is what happens to a short-sighted person. The rays are made to meet inside here. Okay? This is a short-sighted person. Their rays meet inside. So how do you help that person? You are going to give them a diverging lens. So if you want to help a person that is short-sighted, you will come and do this. In front, you put a diverging lens. And it is going to spread out the rays like this, so that when they finally bend, they now meet inside. Yes. Oh, really? Okay. Oh, you mean to put the lens? Yes, yes. Yes, they can put the lens right by your eye. You don't have to wear glasses. Yes, it's possible. So, can you all see how to correct sight? Can you all see how to correct sight, class? Mm-hmm. Yes, he is. He definitely is. Okay, now let's see the questions. Kelly, is this true? Antonisha, are you there? This person is long-sighted, right? When we look at the diagram. So now, how do we fix? That's the very first question. You see? They're asking what I was telling you. Now they're asking you as students, say, how are we going to help this person? How do you correct long-sightedness, class? What are you going to draw? What type of lens corrects long-sightedness? Class, what type of lens? A convex lens. So you come and you put a lens right in front and it should be convex. You put a convex lens with the normal line. These rays are going to come. Let me move it down a bit. Here, we want to fix this problem. So the rays will come. Sorry. It's like this. Then they will bend them a little bit like this. Then when they get here, of course, they'll bend again in such a way that they will now meet here. Have you seen it? This is the lens. that you put. Are we together? Anyone with a question? Can you all see this, class? I'm going to the next one. Have you seen it? It's easy, right? Correcting side. Let's look for another correcting side. It's not number 2. It's not number 3. It's number 4. Can you all see this one? For correcting side. Class? Can you all see this one for correcting side? Right, so how do you correct it? Or draw the path of rays inside the eye to show the effect of long-sightedness. They want you to draw the path to show the effect of long-sightedness. You just do this. Then you put this one. Then you put this one. Then you make them to meet outside your eye. This is the effect of long-sightedness. Are we together? You know what it is. Here, a lens is used to correct the to correct long-sightedness. Draw a lens suitable for this. It's a convex lens. This is the lens which is used to correct long-sightedness. Is there anyone with a question? Is there anyone with a question on this one? Let's look for another one. Here is another one. Let's see if there was no other. Okay. Here is another one. Here is a simplified diagram with raised whatever of a distant object. What does this person have? Clearly this person is short-sighted. His rays meet inside this eye. Here, add an additional lens to outside the eye to correct short-sightedness. There we go. You do it like this. Then. So, for short-sightedness, you need a concave lens. Here's what you do now. Comes like this, spreads, then so here you'd now have it like this. It comes in like this, then it will slightly bend. It's like this. They come together. Then this one. Make them meet. Then you are ready. You're done. This pen is not doing me good. Just make them meet. Here, like this, then like this. Here it is. Ah, why? Come on, respond. This is how you correct long-sightedness. Then you get your 2 marks. Is this hard? There we go. Have you seen this? So questions to correct eye are simple, right? How do you correct short-sightedness? What type of lens do you use? Short-sightedness. What type of lens do you use? to spread the yes, a diverging lens to spread the waves, to spread the rays a little bit more. That's why you see all these rays when they came, they were spread a bit more. So this is how you do it. Now for this one I'm done. I want to now answer the other types of questions. So for correcting sight, you people will answer for me, right? You're not going to leave it, right? It's the simplest thing. Have you seen it? Now, here we are on another question. LGK, can you see this question? Can you read it? Read it quick, LGK. Okay. Now, what is the question saying here? Yes. What is the question saying? Good. Here's the object. Now, what do you want to draw? We want to draw the image. How easy is this? How many lines do you need to find the image? 2. We have this one, which gets up to here. Can you see? You draw this one, then it should now go to the principal focus. Then you draw this one, which starts at the top, and it should pass through the origin. Are we together? Can you see this? Okay. So how many lines should you put on a ray diagram? The important ones. 2, class. This one, which goes straight, then goes to the focal point and passes, or this one. Are we together? So now what you do, so there we go. What we'll do is, let me just, we will now move back if rays don't meet like this, because the rays you use are only 2. One which goes parallel from the top of the object, gets to the center, then bends to go to the focal point. Or this one. Right. What you'll be having is 2 rays that don't meet, so you plot them backwards. So what you do, just trace it back. I don't have a ruler, so it's losing the art. You trace it back where they meet. Can you help me? Something like this. Am I correct? Like, am I straight right now? This is something straight, right? And this is where you now say your image is. Can you see it? Your 2 rays have located it. Have you seen it? These are the 2 rays you should always put. LGK, have you seen it? How many rays do you need on a ray diagram, LGK? Tell me now, let's finish this. You need 2. One which does what, LGK? It goes straight. So the other one is just going, yeah, it will pass through this middle point. Yep. You don't have to. It's called being fancy. or flexing. You don't have to. What you have to put is these two lines, then you can show the image. This is just way too easy. Draw the image, measure the distance from IY. They say draw the image and label it IY. Wherever you're going to label it to say IY is your image. Measure the distance from IY to the principal axis. Now let me just make people understand. Principal axis is this whole line here. Is an axis. It's the only axis we have. We don't have x-axis and y-axis here. We have the principal axis. That's the axis we have, students. Here they want you to measure from the top till you get to the principal axis. They want you to measure this distance here. Are we all together? Are we all together? Am I being heard? Yes. So you measure, that's the distance they want you to measure. Take your ruler, measure it, write it here, centimeters, go on. State 2 reasons why the image is virtual. Now this is the second part of the question. They are now saying, please tell us, why is this image virtual? No, who else wants to answer? Do you know why it's virtual? Our IY. Why is it virtual? Because it is on, tell me. 1. Okay, let me say this. Any virtual image, one thing you must know is you can't project it. So I want you to write here to say it cannot be projected on the screen. Okay? Projected onto a screen. You can't project a virtual image because it's not there. Are we together? Students? Okay. Now, this is the first reason. Then here, now, let's see here. What is, look at the other thing that makes it virtual. Here, what is the distance between the object and the length? Where is the first focal point? It's here, right? When object, let's put it here and make it, because this is just so easy. I hate these small theory questions that will make you look hard. Let's put properties of virtual image. What are the properties of a virtual image? We talked about virtual image last time. We said, when do you get a virtual image? Can you tell me? Here I'm going to tell you, let me tell you for the sake of time because we don't have time. Here are the situations when you are doing ray diagrams. The situation that will give you a virtual image is when you have, here is your lens. Here is your lens, class. You put your lens, whether they want to put it like this, that's another issue. Your lens, here is your lens. I'm just showing you like this. You're convinced. If I'm going to take the distance between here and the point where your rays will be meeting, we say it's a focal length. This is called the focal point, where if rays come and hit here, they are all being focused onto that point here. So it's the focal point where the ray is going to be hitting. Now, you take that distance here, you should also put it on the other side because it helps us. If you have an object which is so close to the lens like this, it's less than one focal point away, it will always produce a virtual image. So when I have, there are 3 positions that we place our object. Listen, class. There are positions that we place our object. 1, we place it between 1 focal length and between 2 focal lengths. So let me put another focal length here. You should know when we have the real images, the places where we place our object. Number 1 is between 1 focal length and 2 focal lengths. So if I come here and I place the object, I call it O. This is how they put it. If I place the object on this position, I am going to get a real image, right? If I come and I place the object exactly at, this is another focal length, we usually put a 2 to shade this a second. If I put it exactly here, I'm going to get a real image again. If I put it here after 2 focal lengths, I'll get a real image again. So these three here, these three positions give me a real image. Are we together? Are you listening? The properties, these positions, just know this is your IGCSE physics. And what you want to know is the real difference, to say, between a real image and a virtual image. What is it that makes it a virtual image, and what is it that makes another image that is being made a real image, right? And here, what I've been telling you is things that will bring those, okay? I did not explain I did not explain the theoretical definition of it, but I'm telling you that when we have an image that we say is a real image, it is because in reality rays are meeting. Look here. Let me say this. Lehakwa, can I ask you a question? In reality, let me erase all this, class. I'm going to erase all this. They said draw, right? Draw 2 rays. And the 2 rays that we always draw will never change. They don't change because of where the object is. Put the object where you want. I'm not interested. So I'm not yet looking. Look, I can easily look and see that this thing is not on the 3 good images. 3 good images start after 1 focal length. The first one will be between 1 focal length and 2 focal lengths. The second one is exactly at 2 focal lengths. The third one is after 2 focal lengths. These are good positions to put the object. We are talking about where you can put the object to get a real image. You can put the object here between 1 focal length and 2 focal lengths. You can put the object exactly at 2 focal lengths. You can put the object here after 2 focal lengths. If you put your object here, you are doing well. You're going to get a real image. What is a real image? It is an image where objects meet in reality. A real image, rays meet. Rays converge. If your object is in here, between 0 and 1, if it's less than 1 focal length, it's way too close. Let me tell you something. It's going to be a virtual image. Sir, what on earth is virtual? Fake. I don't want to use the word fake, but I can use the word fake. I'm allowed. Why are you saying fake, sir? What do you mean by the image is fake? In reality, Lehakwa, the rays never meet. We are going to pull them back to see where they would meet if you trace them backwards. But reality is that they never meet. Are we together? Are we together? So if I draw, comes like this, straight, you put your straight ray, it goes straight from the top. Then obviously, it has to go to the focal point. Or else I don't know what you're drawing. Then you draw the second ray, which starts like this and passes through here. Can't you see they are diverging? Can't you see Sorry for the glitch. Can you hear me? 1, 2. Can you hear me? I apologize. I'll put the Starlink on a stand. It's on a low position. It's not elevated, so the obstructions are big because the buildings are tall. So it's not really catching well. That's the reason why it's doing this. So I'm going to help get that fixed. Can you all hear me nicely? Please, my students, what makes a real image? I want you to all say, a real image is one in which the rays really come together, or the rays converge. The rays actually converge to one spot. They will make a real image. What is a virtual image? The rays do not converge. A virtual image, the rays do not actually meet. They only appear to come from a point if you trace them backwards. But that's a fake image. You can't project it onto a screen. The image is upright. So the rays do not meet. Here is the virtual one. The rays, they look like, they appear to come from a point. This type of image that you are getting from this can never be projected onto a screen. So this is your typical virtual image. I want to finish ray diagrams today. So let me just make sure on correction of sight, everybody's fine. On correction of sight, everybody's fine. You know that long-sighted, they meet outside, they are corrected by convex. For long-sighted, they are corrected by a convex lens. Short-sighted, they meet inside, they are corrected by a concave lens, and they'll meet on the retina. Everybody's fine. Then you now know, let me put that, if I'm going to put the things, let me say here, a real image, I showed you where the object will be for you to get a real image. Real image, if I say, let me put things that people should always remember. The most important thing is real image, let's say real image. A real image is formed, let me put the properties that I don't want anyone to forget, is formed when, 1, light rays, it is formed when light rays actually meet, in brackets, say converge. If light rays do not actually meet, then that thing is not real. That image of yours is virtual. It is not real. If the rays are not going to meet somewhere on one point on the other side where you can now come and say, this is my image, they are not meeting, then hey, Mr. Man, that's a virtual image you have. So the light rays actually meet, they converge. And a real image, the other properties about, so this is what makes a real image. Then I want you to say here, the image, a real image, or let's put it as a property, it's also a property. It is formed when the image can be projected on a screen. But the real reason it's real is the rays meet. So the image can be projected onto a screen. I feel like putting it on its own to say a real image can be projected onto a screen. Now, put this. Real images are usually, if not all the time, inverted. Which means upside down. So, sir, what's a real image? If somebody asks me, hey, what's the difference between a real image and a virtual image? You say, in a real image, the rays actually come together. So the image is real because the rays are coming together. The image is there. Rays are there. They are meeting. It's true. There is something there. The image is there. That's what we mean by a real image. Now, when we say virtual image, that's a totally different game now. When we say virtual image, Are you writing with me? Hello? Let's finish it. Let's finish it. Let's finish it. We want to finish this once and for all. A virtual image is formed. In terms of diagrams, I know everybody is comfortable. You just draw two rays all the time. So it's going to be easy. Sometimes I'll get real, virtual, whatever. A virtual image is formed when, I want you to say, light rays. Okay? When light rays do not actually meet. Light rays don't meet. Hey. Then we'll have a virtual image. The rays only appear, I want to use the right wording here, they only appear to come from a point if you trace them backwards. If you trace them backwards. So rays don't meet on a virtual image? Of course they don't. That's why it's virtual. It's usually on the same side as the object when you are going to find this type of image, this fake, this virtual image. Don't use the word fake. The image cannot be projected. You cannot increase it. You cannot project it onto a screen. Cannot be projected or shown on a screen, projected onto a screen, because there is nothing. There is no image. Rays are not meeting. The image is usually upright. The image is usually upright. So the rays are not meeting? Yes. Your eyes being tricked? Yes. Your eyes being tricked? Yes. There's nothing there. Example of a virtual image is a mirror. E.g., mirror image. Can I ask you a question? Is there actually someone in the mirror there? Is there a person in the mirror? There is no one, right? So it's creating something, right? There are no rays meeting, right? That's a virtual image. Can you put it? I'm sure a lot of you look at yourself in the mirror every morning. That's a virtual image you'll be seeing. It tricks your brain. Pardon? I didn't hear that. I didn't hear that. Oh, a real image. An example of a real image. I think that's what you. I don't know. The audio is not clear. It's a camera image. So say put e.g. a photo. Okay? Or what you see on a projector. Say camera image. Can I ask you a question? The photo you see in a camera, was it actually there? Yes. That person was there. Rays were meeting. It's a real image. But the person who is looking at you in the mirror, who is looking right at you, looking back at you, that's not a real person. That's not a real image. That's a virtual image. Can the image be formed on a screen? No, if it's virtual. If it's real, yes. And is it usually inverted? If it's real, it's usually inverted. If it's virtual, it's usually upright. So we draw, this is typical of a virtual image. State 2 regions why it is virtual. Why is it virtual? It cannot be projected onto the screen. Why is it virtual? Virtual, it is upright. We can kind of say that. It's one of the properties of a virtual image. Why is it virtual? It is on the same side as the object. Why is it virtual? The object is less than one focal length. The object is less than one focal length away from the lens. All these are things we see on virtual images. When you put your object this close, you're going to get a virtual image. That's why it's virtual. Say those things. I hope now it makes sense. Draw 2, whatever. Can you see this next question? I'm sure you're all red hot now, right? Class? Hello? Everybody? So can you see? Look at what they're showing us now. What are they showing us here? They're showing us an image, right? Hello? They're showing us an image, right? And they're asking you to do what? They're asking you to find where the object is. Here is the image. It's a full size. Look where the image is. Can I ask you a question? This image, do you expect it to be real or you expect it to be virtual, guys? You expect it to be real? Look, which side is it on? Which side is this image on? Is it not on the same side as the object, class? Students? Hello? Yes. Pardon? No. Let's read the question. Okay. This is a remember, okay, let me fix those words. I know what you're trying to say. Let me fix those words. Object is original thing before the lens, okay? Then image is what is formed afterwards. Are we all together? Right. So if I get an image like this, should I draw ray diagrams to remind people? Here are the real ray diagrams. Rule number 1. We said, what are the distances that give you ray diagrams? Between one focal length and two focal lengths, right? Let me quickly draw. Guys, never forget this. I'm doing it quick one last time. Look at this. Everybody, pay attention. Just look at the 4 ray diagrams. I'm going to put them all close to each other and I'll make them all very small. So I'm going to repeat this diagram 4 times. Let me make it small. Right, I'm going to put it here. Make it fit here. Then I'm going to copy it. Then I'm going to paste it. And put it like this. Here. Then I'm going to copy, paste it in again. Then I'm going to paste it again. Is everybody seeing? Now, this is the focal length, which means this is where your rays will be made to pass through. So if I come and I put after. It has to be after the first focal length. Okay? If you want to get real images. So I'm going to put the 3 real images and their properties real quick. This is the object, not the image. This is the object, the original one. We go straight. This is how we move from an object, not from an image, from an object. We get to this, then we make it pass through here and continue straight. Okay? Sorry. This is going to be our focal point. So this is a wrong point. Forgive me for this. Right, so the focal point is... Now look at this. If I then take the second one and I make it pass like this, and I make it keep going until it meets this other one. Look at where they meet. Let me just make them meet. Right. This is where we get the image. Class, the image is here. This is the image. Look where it is. It's on the other side. It's upside down. I told you that images are upside down. Didn't I say that? Images are upside down, right, everybody? Yes. So look at this one. It's upside down. If you're going to put its properties between 1F and 2F, you're going to say this is going to be a real image, this is going to be an inverted image, and this is going to be a magnified image. It's bigger. If the object is just after one focal length. Am I being heard? If the object is going to be exactly at 2 focal lengths, exactly, you get an object which is exactly at 2 focal lengths. Then let's see what type of image it forms. All 3 real images are going to be inverted. Don't let me down now. There we go. Now, we make the second one. The second ray passes through. Look at it. The second ray, come on now, passes through here. It keeps going. Don't struggle with the 2 rays. No. Look at it. What can you say about it? It's real. It's inverted as well. But it is the same size. So if you are exactly at 2F, my friend, then you are going to make an image also exactly at 2F. That's the weird thing. The image is going to be formed exactly at 2F. Okay? And it's going to be a real image. And it's going to be exactly at 2F? Yes. And it's going to be inverted just like all the other ones, but it will be same size. Then if you now make it go far away, so this is F, this is 2F. If we now make our object go beyond 2F and we put an object there, look at what type of image we get. We do it like this. Then we put our focal length here. Then the second one here. You should do a more accurate one. So you will make the rays go through the first focal length as they should. Okay? Then the second ray, of course, comes like this. And look where it is. Look where the image will be formed. This is the image. It's real. The image is real. The image is inverted, but it's smaller. So we say it is diminished because this object is just way too far. But at least, although it's way too far, at least it's real. At least it's real, guys. So yes, okay, you are far, but at least you're real. These are the 3 real images. Class, don't let me down. Look at the real images. It's only these 3. What I want you to see is, the first thing, I want you to see where the object is placed. After the first focal length, but before the second one, or right at the second one, or after the second one. What do you get? After the first, it will be a magnified image. Right at the second, it's the same size. Now when you go too far, it's now going to be diminished. It's now going to be smaller. Am I being heard? Students? So, how can you tell me that if this is the image, it's real? How can you say that? All the real images were this side and they were inverted. So how can this fake, I'm saying it so that you get it, how can this virtual image be considered real? Look where it is. It's upright. It's on the same side as the object. Images are never on the left. Images are never this side. So how come he's this side? Because he is virtual. Okay? Do you understand? Hello? This is the most virtual image I've ever met in my life. We know what happens with virtual. You just come on the very majestic, these 3 beautiful real images that are real, where the rays are actually meeting. The rays are actually meeting at the point. These 3 great real images. Then you come and you change something. You put your object just so close. You come and put your object before one focal length. You come and you put your object. We know what's going to happen. We know what's going to happen. We say to you, please tell me, what is going to happen? You say, you know. The rays will diverge. They will never meet. Really? Yes. So what do I do? Let me trick my brain. Let's trace them back to make them, because they look like they can emanate from a point. So it's like they come from a point. We trace them back, then we'll see where they meet. That is here. This is where you put an image, but it's a virtual one. No real rays are meeting here. It's a virtual one. So you saw it here. Are we together? Students? You come and you say, this image is virtual. This image is upright. This image is magnified. They like these words. Are we together? Magnifying glass. Let's see now. Here. What are we supposed to do? Mark 2 points with labels F to show the positions of the principal focuses What is the principal focus? The focal point. Okay, F. Okay, give me a second. This thing is seeming to be, is looking like it's fighting me. So let's see here. With labels F to show the positions of principal focuses of the lens, the focal points. So in other words, if I come like this, I'm going to the focal point. Make sure when you put a focal point, measure the same distance and put it here. You have measured you have done the focal points. There is going to be, if I come here, they say draw two rays to locate the object. Look at me being naughty. I can pretend like the object is here. If because it just has to be between one focal point. So what would happen? We know that we would have a ray that comes like this, straight. Then this ray would bend and go past here. Then another one went like this. So if I then follow, will it lead me here? No, it doesn't. I needed to lead me here. So let's do it again. We needed to lead us here. So we would, let's do it again. We could just take from here. Here's another tip I can give you. Go to the image where it is. Put a line that goes straight passing through here. Just like you did for the object. Then make it continue. Then, when you do it, you just need a second line, not even anything. And how you get the second line is you would say the object is like this. So the second line is going to be this one, which would be, you would trace back like this. Right, and here you would now do it and make it pass through the focal point here. These rays will never meet. So this is something like this. Have you seen? Draw two rays, draw the object and label it O. So they say draw the object and label it O. Okay, I saw it somewhere here. Yes, label it O. You get 3 marks. Draw 2 rays. Here are the rays we've drawn. You know, with the ruler you do a better one. Then here, from this object. You start here, you make your ray pass through the center. It continues. Any questions? This is the important ray class. This one, make sure when you are trying to find where the object is, do this ray here from a virtual image. Then you can make a line which connects. That line should obviously then be dotting like this. And do to follow, no lead. Any question? Is there anyone with a question? They now want to move the object. They say the focal length is 3. So you measure that 3 and you put the focal length on both sides. Then they are now saying the object is going to now be at 6 centimeters, which is 2 focal lengths. So we want an object exactly at 2 focal lengths. What do you know about an object that is exactly at 2 focal lengths? From what we did on top there, what are its properties? They say it's stage 1 characteristic of an object. We say the image is the same size. The image is the same size as the object. The image is the same size as the object. Okay? You should know more than me. You should know more than me, class. You should know more than me. That at 2F, exactly at 2F, it's same size. Come on now. You should know more than me. You should actually remind me, sir, when it's exactly at 2F, you get it being the same size. Are we together? Students? Good. All good? So them saying we put it at 6 centimeters, what? You know that one focal length is that. You should just translate what it means. They said we are moving it to be 6 centimeters from the left. You should just translate it to say, is it before the first focal length? Or is it between, because you know that you know how to know. Is it between 1F and 2F? Or is it at 2F? Or is it after 2F? Use this, what they've given you to see, and you'll find that it is at 2F. Now you know if it's at 2F, you find exactly the same size. Any question? Anyway, correction we did. He drew this. Really? Do they want me to draw? Draw the magnified image. Explain the meaning. Here's the first thing. IGCSE physics students. These definitions you cannot ever not know. The principal focus is meaning and the focal length, okay? And any other important one on ray diagrams. Let's put them. Important definitions. Only 3. Principal focus. Or should I? What is the principal focus? Or should I no, principal axis. Let's start with the principal axis. It's an axis, so it's that horizontal line that moves like that. That's the principal axis. What is it? I want you to say, it is a straight line that passes through the optical center of a lens and is perpendicular to the surface or to the normal. So it's like your lens. It's like this. This right at the center is the optical center. Right at the center of your lens. If you now bring a horizontal line which passes through there, that is going to be the principal axis. A straight line which passes through the optical center of a lens. It's the main reference line. All the ray diagrams will be working with this thing. This straight line. Then, what was the other one? The principal focus or the focal point. Principal focus, not principal axis. Ish. Principal axis, we've seen it. Now we are talking about principal focus. Principal focus. Or the focal point. The F. The focal point. Or principal focus. The F. What is it? This is, let me see how I wrote this. Okay. This is the point where rays parallel to the principal axis converge. This is the point where the rays parallel to the principal axis meet after passing through a lens. After passing through a convex lens, obviously. Are we together? Any question? Which rays do they mean? The rays that are parallel. They mean these ones that come like this. They are all made to go onto the principal focus or the focal point. It's the point where the rays that are parallel to the principal axis are made to are focused onto by the lens. Any ray which comes horizontal like this is taken there. Are we together? So, what now is the focal length, the last one, the third and final definition? Then you are done with definition. What then is the focal length? I want ray diagrams. I hope somebody is writing my notes on the exercises themselves and also adding with these notes. I hope you're writing my corrections and also adding with these notes for yourself. Students? What then is the focal length, sir? It is the distance between the optical center. We saw the optical center right at the center of the lens. And the principal focus. Principal focus is a point. Hey, you! Principal focus is where all the rays are being made to go. Then focal length is from there, the principal focus, to the optic center. All together. Are we together? Still? Shalom. Focal length is from where to where, Shalom? Shalom. Focal length is from where to where? Litohonolo. Focal length is from where to where? From the optical center to another point, which is the principal focus. It's between 2 points. It's between 2 points. This point, optical center, which is here. This point to this point here. This distance between 2 points. Optical center and the focal point or principal focus. The distance becomes the focal length, F, which we like to put F here. And you're done. Thank you for your attention to this matter. So come and define and describe and do it. These theories, be ready for them. They can ask you, hey you, come here. What is the principal focus? Principal focus is a point. It's a point, it's not the axis. So tell me what the principal focus is. I told you. It is the point where all rays that are parallel to the principal axis are made to converge when they pass there. Are we together? principal focus right there. It is the point where rays, it's a point where rays parallel to the principal axis. Parallel to the principal axis converge. It is the point where the rays that are parallel to the principal axis meet. They converge after passing through the lens. If you are just a flat line and you pass through the lens, you are going straight to the principal focus, my friend. Whoop, whoop, whoop. Focal length now. Distance between, you see the three definitions I gave you? They're important. Distance between optical center and principal focus. Questions? Questions? Draw the magnified image. Show you're working. Are you going to really ask me to draw an image? Really? Are they really asking us to draw an image? It's obviously a virtual image, which we know that this virtual image is actually a magnified one. So, and this one. So it's like this. Give me a second. It's like this, sorry. And like this. How will they ever meet? Like, honestly. Here. So it's like this. Then you trace it back. You already can see that the object was before one focal length, so we were expecting it to be virtual. Here you trace them back. And you are going to form a magnified upright image. Draw the image, show you're working. I've drawn it, I'm done. You can come to the next question. Okay? Come on, guys, these questions were not hard. Were they hard? Did anyone find these hard? Hello? Were they hard? I don't think so. Right. Show the lens. The lens of a magnifying is a converging lens. Show the lens of the magnifying glass. Its two focal points, f1 and f2, and its principal axis. These things are shown on figure 4.1. They said figure 4.1 shows this. Now, state what is meant by focal point. We talked about it. It is the focal point. It is the place where all the rays converge. Rays that are parallel to the line. You can define this, eh? Write the definition. I gave you just now 2 points. Hey, choose them, whatever. A point X on the principal axis for a possible position of the object. Point E for a present position of the student's eye. On figure 4.1. Underline 2 words that the image produced. Okay, so here we have a magnified image of an object. Are you hearing me? So we are having a magnified version. Okay. How do we get it? Class, we are going to take our object. Okay? Let's draw. They said we should put what point? They said put X as the position of the object. Can you see that? Why are you so quiet, class? Can you hear me? All of you? Lekakwa? Are you in class? Lekakwa? Okay, so here we now keep going. Magnifying glass. Just put a possible position of your object, then call it X. Here, I'm trying to change to black. I don't know why it's refusing. Where is black here? Okay. All we want to see is where is the object when we want to draw the image of a magnifying glass. Where do we place an object? So I'm going to use, okay, maybe this red is okay. Right. So here is the diagram. Focal length, we put our object here. And this, the length is way too small, so we put the object like this, so that it can now go to, because the length is way too small. So it's gonna come, get here, then go through there. Here's the first thing you do. Then the second thing you do is you draw this one, the one we've been drawing. Then you make it continue. And here you trace back. Sorry. Here, you now put your image. Okay? But it's usually a little bit far. I don't know why this one is close. Here, it's a bit of how it comes. Usually they meet after 2F. So here, this is going to be like that. And what did they say we should call our object? X, then E. X is the project. Then E. Okay. Are we together? Good. That's the magnifying glass. Upright, virtual. There we go. Now you can do these other ones, right? Draw the ray diagrams. I'll give them to you. If you get stuck, you tell me. Okay? Students, did you see this? All right. That's it for ray diagrams. Physics. Mm-hmm. Yes. Is it necessary to put the dotted lines on your lens? No. You know why I put them? Look at these guys. Cambridge likes to put one. Have you seen that? It just shows you know that all things bend at the normal line, because your diagrams should show waves bending at the normal. Okay? Mm-hmm. I should go back to the second question. Yes. The long-sighted man, when we draw what? Yes. Yes. Just show them meeting outside. It's a sketch, so it doesn't give you too many marks. It's just like 1 mark. It's very rare for it to be 2 marks. Okay. Yes, Devin, I can see the chat. Seth, hi. I can see you on the chat. I'll do electricity and magnetism again. Very soon. I'm about to. I'll finish this one very soon. We'll have long lessons over the weekend, guys. To do a bit of before people open schools. Some of those who haven't opened, and before those who have opened, get a lot of assignments and stuff. We'll do a long lesson, and it'll be long. So make sure you're ready. But it will be fun. I can guarantee you that.